Okay. Okay, members, welcome back for the next session. Still I'm Teacher Kasozi, taking in chemistry. We are on our topic of salts. We have seen how we can prepare various types of salts. So in the other previous discussion, we have looked at preparation of insoluble salts, and we have seen that an insoluble salt, that is a salt which does not dissolve in water. Once it dissolves, gives what we call a suspension. And the suspension, that is a liquid containing solid particles which spread throughout it, and those particles settle down on standing. Then we looked at various examples of insoluble salts. Say carbonates, all carbonates are insoluble in water, but exception of sodium carbonate, exception of ammonium carbonate, exception of potassium carbonate. The rest are insoluble in water, can be obtained by precipitation method. Another salt is the all sulfates of barium, sulfates of calcium, sulfates of lead, chlorides of lead 2 chloride, chloride of silver, and mercury 2 chloride are all insoluble in water, and iodides, especially lead 2 iodide, is also insoluble in water. So we are continuing with our preparation of insoluble salts, and basically we are going to look at preparation of lead 2 chloride. 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 We've said earlier that on the other previous discussions that these insoluble salts we prepare them using 2 aqueous solutions. One solution having the cation, the other one having the anion, such that once the cation comes into contact with the anion of that salt, a reaction takes place and brings out that insoluble salt. Why do we say it a precipitate? Because it is obtained when we mix 2 aqueous solutions. So lead 2 chloride, since this is a chloride, chlorides are obtained from hydrochloric acid. So we can use hydrochloric acid to bring us a chloride, and a solution of lead, a soluble salt of lead. The soluble salt of lead is the lead 2 nitrate. And we can use, if not hydrochloric acid, we can use a soluble chloride. Soluble chlorides of sodium chloride, ammonium chloride, potassium chloride, those chlorides which are soluble in water. So long as it can give us the chloride ion, then reaction can take place. So, send to a solution of lead 2 nitrate, solution of lead 2 nitrate, at dilute hydrochloric acid, hydrochloric acid, add dilute hydrochloric acid. From there, after adding, a white precipitate is formed. A white precipitate is formed. white precipitate is formed. Then you continue adding. Here it may not shake, may not stop, because the moment you add, the precipitate starts to form. Continue adding dilute hydrochloric acid, why? To ensure complete precipitation such that all the lead 2 ions have been precipitated out as lead 2 chloride. That's why you have to add more acid to ensure complete precipitation of the lead 2 ions. To ensure complete precipitation, to ensure complete precipitation. Okay? Then we filter off the precipitate. Or if you don't filter the precipitate, what we do, we allow to settle allow the mixture to settle. And decant off the liquid. And decant of the liquid. You allow the mixture to settle and decant of that liquid. Then we wash the liquid, wash the precipitate, with cold distilled water. And dry it between filter papers. Right between filter papers. Why do we say with cold distilled water? Because lead 2 chloride is the only insoluble salt that can dissolve in hot water. It's the only insoluble salt which can dissolve in hot water. So if you use warm water, this salt will dissolve. But for lead 2 sulfate, you can wash in what? Hot water, because it remains insoluble, though water is hot or cold. But lead 2 chloride can't wash it in hot water. Then after we produce our equation, which is the lead 2 ions plus chloride ions, you get lead 2 chloride. Our task is to balance that equation, and that is lead 2 chloride prepared or produced in the reaction. So we have a note to take. Lead 2 chloride dissolves in hot water. Lead 2 chloride dissolves in hot water. Lead 2 chloride dissolves in hot water and redeposits back on cooling. You can't say redeposits back, then you can say reprecipitates out. Or recrystallizes out on cooling. Because you may find a second question. Lead 2 chloride was dissolved in water and the mixture heated, then allowed to cool. State what was observed. Give a reason for your following the observation you have stated in A above. Okay? That if the chloride is dissolved in water and mixture heated, then allowed to cool. It means that the white solid will dissolve, giving a colorless solution, because solution of lead 2 iron is colorless. So if it is in hot water, lead 2 chloride will have to dissolve to give you a colorless solution. If you leave that solution to cool, then we shall receive back a precipitate. Deposits back on cooling, reprecipitates out on cooling, or recrystallizes out as white crystals on cooling. Okay. Recrystallizes out as white crystals, white cubes on cooling. Reason being that lead 2 chloride has a higher solubility in hot water than in cold water. Let me set a question here. Let me set a question. Before setting the question, let me come to lead 2 iodide. Go and rotate there. It's also lead. So it was lead 2 iodide. Preparation of lead 2 iodide. Preparation of lead 2 iodide. Preparation of lead 2 iodide. So, since we've said we need a solution of iodide ions, so here we can use potassium iodide or sodium iodide, because we cannot have ionic acid, hydroiodic acid here. You don't have it, so you can use potassium iodide or sodium iodide on the solution of lead 2 ions. Lead 2 iodide is precipitated as a yellow precipitate, unlike salts of lead which are white in color. But lead 2 iodide will be precipitated out as a yellow solid, which is the yellow precipitate. So here we say to a solution of lead 2, solution of lead 2 nitrate, comma, add lead 2 iodide solution, add lead 2 iodide solution, yellow precipitate is formed. So we continue to add lead 2 iodide. Why? To ensure complete precipitation. Continue adding lead 2 iodide. Continue adding lead 2 iodide to ensure complete precipitation. Complete precipitation. Stop. Filter of the precipitate. sheet, wash the residue with little cold distilled water. All solid iodide is insoluble in cold water, but also dissolves in hot water, like lead to chloride. Lead to chloride dissolves in hot water, even lead to iodide dissolves in hot water. Cold distilled water and dry between filter papers. And dry between filter papers. And dry between filter papers. That would be Dd2 ions plus iodide ions. Then you get Dd2 iodide. So this is obtained as a yellow precipitate. It's obtained as a yellow precipitate. Then, if we are testing, let us put this note, potassium iodide, potassium is called sodium. Sodium iodide can be used to confirm lead to ions in solution. We confirm lead to ions in solution, because if you are confirming lead to ions, then to a solution of lead to ions we add potassium iodide or sodium iodide. Then product shall get a yellow precipitate formed in the reaction. And lead to iodide, like lead to chloride, lead to iodide, dissolves in hot water and crystallizes out on cooling. Dissolves in hot water and recrystallizes out on cooling. Let me get a question here. Question on this preparation of insoluble salts. Part A. Stage. Roman 1. Stage. Roman 1. The laboratory method. Method of preparing lead to chloride. Study about the method of preparing lead to chloride. That's Roman 1. Roman 2. The reason for the choice of the method. The reason for the choice of the method you have stated. You have stated in A, Roman 1. Roman 3. Two other examples of salts prepared by the same method. prepared by the same method. In A, Roman 1. Part B. Part B. Lead-2 chloride. Lead-2 chloride was dissolved, was put in water. Don't dissolve because it does not dissolve. Was put into a beaker of cold water. Stop. The mixture was shaken. Mixture was shaken and the product allowed to cool. And the product allowed to cool. Allowed to cool. State what was observed. State what was observed. C. Name one reagent. Name a reagent that is used, that can be Roman 1, that can be used to confirm leading to ions in solution. Ions in solution. Roman 2. State what is observed. What is observed. When the reagent you have named in C1 is treated with the solution, of Ld2 ions. Roman 3. Write an ionic equation. Write an ionic equation of the reaction to illustrate your answer in C, Roman 2. So that can be the question I set here on insoluble salts. If you have got the content, state a laboratory method of preparing Ld2 chloride. The reason for the choice of the method you have stated. So you have to give a reason why Ld2 chloride is prepared by the method you have stated in A1. Then you list 2 other examples of the salts prepared by the same method as Ld2 chloride. Then if we dissolve it in water and we heat, what do we observe when the mixture is allowed to do what? To stand. Then name a reagent that can be used to confirm Ld2 ions in solution. What is observed when the reagent you have named in C1 is treated with the solution of Ld2 ions? Write an equation to illustrate your answer. This will take a half mark. This takes a half mark. This takes 1 mark. This takes 1 mark. Those are 3 marks, isn't it? 1, 2, 3. Name a reagent. This will take half mark. Half mark. Those are 4 marks. This is 1.5 marks. So the whole question takes 5 marks and a half. No question. So you can do this question in your time and you see other salts. Young So that is on insoluble salts. So there is another method of preparation of salts, and that one is so have this method, direct synthesis or direct combination. Synthesis or combination. Direct synthesis method of preparation of salts. So this method is used to prepare the liquescent salts, most especially liquescent salts. This method is used to prepare the liquescent salts. Only examples of salts. Why do we say the liquescent salts? Because these are salts which absorb water from the atmosphere, and after absorbing that water, they dissolve in the water to form solutions. So we cannot prepare them using crystallization method. Because in crystallization, we evaporate to near dryness or saturation point. Meaning that for those salts, they cannot exist as crystals. They would be in solution form. So for them to be prepared, we basically combine elements together. Examples of such salts prepared include, you can have aluminium chloride, there is anhydrous hydrous iron chloride, calcium chloride, These salts are prepared by direct heating of the metals in a dry stream of chlorine gas. For example, iron 2 chloride, iron 3 chloride, iron 3 chloride. Iron 3 chloride is prepared by passing a dry stream of chlorine gas through a combustion tube containing heated iron wire. So when iron wire is heated, iron wire heated in chlorine gas, so this would give us iron 3 chloride. Shall not get iron 2 chloride. For iron 2 chloride will be obtained when we pass a dry stream of hydrogen chloride gas into a combustion or through a combustion tube containing heated iron. Heated iron, this will give us iron 2 chloride plus water hydrogen gas. So here, let's pass this equation first to there, 2, 3. So in this case, when we pass chlorine into a stream of heated iron, so here we would say heated iron glows red hot, giving reddish brown vapor, reddish brown vapor, glows red hot, giving reddish brown vapor that settles as black crystals, stroke sublimate. That settles as black crystal stroke sublimate. So this is obtained as a black solid, but since iron 3 chloride sublimes on heating, therefore it first comes out reddish brown vapor. So on condense or on settling or on cooling, then we get black crystals. So iron 2 chloride is also prepared by the same method, but for iron 2 chloride we use hydrogen chloride gas. So when hydrogen chloride is passed over heated iron, here we shall say heated iron glows red hot, forming a white solid. This is obtained as a white solid because the reaction does not involve water. We are passing a gas. So iron 2 chloride, iron 3 chloride, aluminium chloride, calcium chloride, it is anhydrous, zinc chloride, magnesium chloride. All these salts can be prepared by the same method, direct synthesis. We directly heat these elements in dry chlorine. Can get copper 2 chloride, you heat copper in dry chlorine. Can burn magnesium in chlorine, magnesium will catch fire and the end product will be a white solid or white crystals. So why do we prepare them using direct synthesis? Because the salts are highly deliquescent. That's why we prepare them using direct synthesis. So in the next discussion, we shall see effects of heat on salts. Then we shall end with hydrolysis of salts. I beg to stop here for today. Stay safe. Corona is real. Don't move. Wear a mask. Thank you.